Hi guys, this is Arpana from Sri Venkateshwara College of Engineering of Electronics and Communication Engineering. So today I am going to explain you about the Thevenin's theorem along with the example. Introduction to Thevenin's theorem. So Thevenin's theorem, it is a basic fundamental principle which we will be using in the electrical engineering. It will be simplifying the complex network into a equivalent circuit. It also allows us to analyze and also solve the electrical circuits. Statement of Thevenin's theorem. In any bilateral network with output terminal A and B as shown in figure A, it can be converted into a single voltage source VTH in series with the impedance ZTH as shown in figure B. The voltage source is called as a Thevenin's equivalent voltage source, and it is also equals to the open circuit voltage which is measured across the load terminal AB. So as we can observe in this page, there are two figures, that is figure A as well as the figure A. So the statement is representing that in any bilateral network with output terminals. So in figure A, we are giving the output terminals name as A and B, and it can be converted into a single voltage source VTH in series with the impedance ZTH as we can observe in the figure B. And whatever the VTH, that we will be calling as a Thevenin's equivalent voltage source, and it is also equals to the open circuit voltage. And the whatever the ZTH we got, that we will be calling as a Thevenin's impedance, and it is also equals to the total impedance of the network measured from the load terminals by making all the source of the network. So now we have to prove the Thevenin's theorem. So now I am considering the network has shown. There are three resistors along with the one load resistance and the voltage. So by using the current division rule, or it may be a branch current formula, I got IL is equals to R2 divided by R2 plus R3 plus RL into I. Let it be equation 1. So in order to find the current, I will be rewriting the circuit. So like this I will be rewriting, but here we can observe this R2 is parallel with the R3 plus RL. So while simplifying this equation, we will be getting as R2 plus R3 plus R2 RL divided by R2 plus R3 plus RL. So from the above network, I will be applying the Ohm's law. So we already know that I is equals to V by R. So V I will be writing as it is. Instead of R, I will be taking R1 plus R2 which is parallel with R3 plus RL, right? The simplified equation we got is R2 R3 plus R2 RL divided by R2 plus R3 plus RL. So after simplifying the above equation, we will be getting I is equals to V into R2 plus R3 plus RL divided by R1 R2 plus R1 R3 plus R1 RL plus R2 R3 plus R2 RL. Let it be equation. Now I will be substituting this equation with equation 1. So after the simplification, I will be getting the other equation, that is the final expression of the Thevenin's theorem, that is I is equals to V R2 divided by R1 R2 plus R1 R3 plus R1 RL plus R2 R3 plus R2 RL. So I should verify whether the equation is correct or not. So first step is to find the VTH. So in order to find the VTH, we will be removing the load resistance, that is RL, and we will be making the open circuit voltage across the AB terminals. So as we can observe in this figure, I have removed the load resistance and made it as a open circuit. So VTH is equals to IR2 based on the formula I have taken, that is VTH is equals to VA minus VP, that is voltage across the terminal A and voltage across the terminal B, where voltage across terminal B it is grounded, so I will be considering 0, and VA we already got that IR2 by applying the Ohm's law. V is equals to IR, right? So VA is equals to IR2. So VTH is equals to IR2, and we already know that I is equals to V by R1 plus R2. So final equation we got is VTH is equals to V into R2 divided by R1 plus R2. Now step 2 is in order to find the RTH. So I will be making all the sources in the network 0 and I will be measuring only the total resistance of the network. So here there are three resistors. The two resistors are parallel and the one resistor is in series. So RTH is equals to where R3 is series with R1 and R2 where R1 and R2 are parallel. So R3 plus R2 divided by R1 plus R2 final equation I will be getting as RTH is equals to R1 R3 plus R2 R3 plus R1 R2 divided by R1 plus R2. So step 3. So in order to find out the equivalent current, I will be reconnecting the load resistance across the A, B terminals. So finally, I have connected all the circuits, that is VTH, RTH and the RL. So here I should find out the IL. We have the formula, that is IL is equals to VTH divided by RTH plus RL. So we already know that the value of VTH as well as the RTH. So substituting the two equations in the IL formula, the final expression we will be getting as IL is equals to V R2 divided by R1 R3 plus R2 R3 plus R1 R2 plus R1 RL plus R2 RL. So comparing these two equations, that is equation 3 as well as the equation 4, these two equations are equal. So hence the Thevenin's theorem is proved. So let us take one example based on the Thevenin's theorem. So now I'm taking one of the example, that is find the current flowing through the 6 ohm resistance for the network shown below. So here there are three resistances. One is 4 ohm, the other one also 4 ohm and the other is 2 ohm, and I'm considering the load resistance, that is 6 ohm, as well as I have got the current, that is 5 amperes, and the voltage is 4 ohm and the 5 ohm. So first step is we need to find out the VTH. So in order to find that, we should remove the load resistance across the 6 ohm and we should make it as an open circuit. So after that, VTH is equals to, we have formula, that is voltage across the A terminal and voltage across the B terminal, right? So where VB is equals to 0 because it is grounded. So I will be getting VTH is equals to VA only. So now I will be applying KVL for the loop 1. For this loop 1, I will be applying KVL. So from here, the current will be flow. So minus 4 and V is equals to R. We already know that I1 4 and I1 4 and also 20, which is equals to 0. So here 4I1, it will becomes 8I1. So 20 minus 4, it will be 16. So while we will be replacing minus 16, we will be get. So I1 is equals to minus 2 amperes we will be getting. And VA is equals to, we already know that 4I1 plus 20 minus 5. So across the A terminals, voltages across the A terminals, I will be considering 4I1 plus 20 minus 5. Simplifying, we will be getting VA is equals to VTH is equals to 7 volts. Then step 2. So in step 2, we need to find out the RTH. So I will be making all the sources in the network 0. So here I will be getting three resistors. So two resistors are parallel and the one resistor is in series. So where 4 and 4 are in parallel and 2 is series with that. So RTH is equals to 4 into 4 divided by 4 plus 2. So RTH is equals to 4 ohms we will be getting after simplifying the expressions. Then step 3. So we will be writing all the equivalent Thevenin circuit. So after writing, we already know that IL formula is VTH divided by RTH plus RL. From the above equations, we got the value of VTH, RTH, right? So VTH is equals to 7 volts and RTH is equals to 4 ohms. So by simplifying that, and also RL is equals to 6 ohms. By simplifying the equations, we will be getting IL is equals to 0.7 amperes. Conclusion. So Thevenin theorem, it is a powerful tool which is being used in the electrical engineering and it will be simplifying the complex circuits and also allows for the easy analysis. But understanding and applying Thevenin theorem is most essential for solving the electrical circuits. Thank you for giving such an opportunity in order to explain about the Themnian theorem.